I'll give you an example. It's built off of this guy, actually. But 3 is a bit pedestrian, so we're going to ramp it up a little bit. Let's go to 7. Okay. What I want is a general term for these coefficients. The kth coefficient, if I have the kth one, that'll tell me the k plus 1. Okay. So as usually is the case, if you want to generalize, you build a pattern first. Okay. So what's this thing equal to? If I were to expand it just like I expanded these guys, okay, what would I get? First term. I'm going to put it in terms of the coefficients. Okay. I could write 1, but I'm trying to generalize here, right? That's what writing in NCR notation or these bracket notation is useful for. Plus. Okay, the next one over, 7 choose on, which will be 7. I know you recognize that. Now, what will be attached to it? 1 lot of 2x. Okay? Now, I move over one more time, and I think that's probably enough to establish the pattern. How many lots of 2x? Right, k, right, that whatever that is. Okay? And then I'll finish. Last one, 7, 7, 2x to the 7. Okay? Now, look, all I want is the coefficient. All I want is the number out the front. I want to not have to worry about those x's. Okay, so I'm going to write one more line here to tease out the coefficient, to tease out the c. Okay, so I've still got 7, 0 here. I've got 7, 1, and then I've got 2 and an x. Is that all right? Put the 2 on his own. Here, how many 2's do I have? Well, I have 2 of them. It's 2 squared. Right? 2 squared, x squared. And then when I get to the end, I'll have 7 of them. 2 to the power of 7. X to the power of 7. Okay, now I can write, that's enough to establish the pattern. Therefore, ck equals, what's the coefficient part? Can you see it there? It's here, then it's here, then it's here, then it's here. How would you write it? It's going to be 7 ck, right? Like that. And then it'll be 2 to the k. Excellent. You guys are on the ball. Good. Now, this is the general coefficient. I want to compare these two. I want this. Okay. The next one to be bigger than the current one, right? Now, please don't skip to this step, this one, without saying this. Now, you don't have to say it in this language, but I'm just going to write it in the shortest language I can. Okay? ck is greater than 0, 4, all the values okay. Okay, now you can write that out as a sentence if you like. It means the kth coefficient is positive for all values of k that are positive integers. You kind of have to say that much, or you can just use the symbols. Okay? It's just noting the restriction. You can't just divide by stuff if you don't recognize it's not going to screw up your inequalities. All right, now, I know what this is. I can express it because this is the general term. Okay, so watch. It looks a bit monstrous, but that's okay. It's 7, choose k plus 1. There, that's what's on top. Right? Times 2 to the power of k plus 1. Good, that wasn't so hard. And then I've just got this guy on the bottom. That's greater than 1. Okay, I've run out of space. So now you have a look at this. We have been practicing with our factorial notation and with our NCR notation. We know what it means. So we're going to need to expand some of this, unroll some of it, if you like, so that we can start to simplify it out and turn it into less of a bit of a dog's breakfast. Okay. So, okay, what am I going to write? 7 choose k plus 1. Let's just go after this guy. What is that equal to? Do you remember what the binomial theorem told us the definition of this was? It starts with a 7 factorial over, I think it's k plus 1 factorial. Now, there's another factorial here, but what is it? Yeah, it'll be this minus this, right? This minus this, so that looks to me like 6 minus k. Is that right? Factorial. Okay, that's what's on the top. This 2 to the power of k plus 1, I could leave it like that, but just to make it a little more obvious, I want to cancel it with it down the bottom, right? So the difference between that is just a factor of 2. That is 2 to the power of k plus 1. You content with that? that okay? Cool. All right. Denominator. Actually, it's not as bad because what you've got there is 7 factorial on k factorial 7 minus k factorial. That's just quotient, right? And then there's your 2 to the k. It's all greater than 1. Okay, let's do some simplifying. What can I cancel? I can get rid of these guys. Bang, bang. Okay, what else can I get rid of? Okay, so these guys are just the same. Okay, now, what's happening here? On the denominator, I'm dividing by a fraction. So this guy, I'm going to put it all at the top. You okay with that? Dividing by division means multiply. So I'm going to get that 2. Okay, factorial there. Now I'm going to write this, I'm going to unroll it one step, right? Can you see why I'm going to unroll it one step? It'll be 7 minus k. The next one after that will be 6 minus k, factorial. See that? So I unrolled this a little bit. Then I've got this guy. Just like the 7 minus k, I'm going to unroll this guy one step. K plus 1 times what? K factorial. Good. Okay. 6 minus k factorial greater than 1. Excellent. Now I can do another round of cancelling because I've done this right. Okay. Cancel, cancel. Cancel, cancel. There you go. Okay. So we've evaluated all our NCR notation. We've gotten rid of all our redundant extra powers. All of this stuff, like I can't really take it anywhere else. I just have to expand it out. 14 minus 2k all over, all that's left is k plus 1. Is that okay? Cool. All right. So, by the way, if you were looking at this and thinking, why on earth do we put this all together as a fraction? Why don't we just deal with it as separate signs? The reason is so we could do all of this cancelling business. Now that I've done that, I am going to put it back over the other side. Okay, so 14 minus 2k is greater than k plus 1. I can do that. I've already established why I can do that because I've said that k is going to be positive integers. No problem. What am I trying to do now? Solve for k, right? Happy with that? Divide through. Watch the inequality. What's that? 4 1/3? Is that okay? All right, now what does this mean? What does this mean? Don't forget that k is an integer, right? So I'll say, but k is an integer. Okay. Therefore, this is true. This, where is it? There it is. There's what we started with. The subsequent coefficients are going to be increasing. This is true for what values of k? What values of k? For k is, well, 0, it'll be true. 1, it'll be true. And 2, and 3, and 4. Okay? So, what can I get out of this? Do you remember how before we wrote down these guys? Right? We wrote down that many because that's how many terms we've got. We've got a few more terms this time because I raised the power. Okay, so we're going to get this many. There we go. Okay. Now, armed with this knowledge, I want us to fill in the inequalities that go here. Okay? Which way do the inequalities go? What's my first one going to be? It'll be less than, right? Because this one's bigger than that. And then it'll be less than again. Because this one is bigger than that. How far do I go? Well, look at this. Look at this. You can look at this biggest value. That'll tell you how far you have to go, right? For this biggest value, what does this mean? It means when k is 4, it should be C5 is greater than C4, right? Or if I turn that around the way that I'm actually interested in, C4 is less than C5. Okay? So I go less than, less than, less than, and then it transitions. Okay, so which one's the biggest coefficient? C5. There he is. Okay? He's at the top of the mountain, if you like. Okay? So I would say, sorry, I'm just run out of space, but you would keep going down. The greatest coefficient is Okay, now C5. I actually know what C5 is because I went to all the effort of, except that I rubbed it off, working out what the kth coefficient was, right? So, actually you can help me, right? I think we said it was C5, which is 7 choose 5 times 2 to the power of 5, yeah? Now from memory, that's 2 over, I think that'll be 1, 7, is it 21? I think it's 21. Yes. 21 times 32, yeah? Okay. 640, 672. Cool. Okay, does that make sense? You happy with that? Okay, now, I have a secondary part of this question, but I'm not going to hold your hand through it, at least not yet. I want you to have a go. You know how all of this started with? It started with this guy. Remember that? Okay. So what I want you to do is, now I want you to answer the question again. I'm still looking for the greatest coefficient, but I'm looking for it in a particular case. I want it when that is true. Okay, because it's just a function of x, right? You can put any value of x in there that you like. Sometimes we put in 0 because it makes things collapse neatly for us. This is going to skew the pyramid of coefficients in a different direction. So I want you to see if you can work out which direction it goes in, what the greatest coefficient, what is this going to look like, and therefore what number will you end up with?